Imagine stepping through a doorway and instantly arriving at a planet orbiting our nearest star, 4 light-years away. Or climbing aboard a city-sized spacecraft that will become home to 1,000 generations. These aren't just science fiction fantasies anymore. They're the 3 most promising paths humanity is actually pursuing to reach the stars. Right now, as you watch this, brilliant minds around the world are working on technologies that could make interstellar travel possible within our lifetimes. Some involve bending the very fabric of space and time. Others require building spacecraft the size of cities. And one ambitious project is already testing tiny probes that could reach another star system in just 20 years. The question isn't whether we'll reach the stars, but how, and the answers might surprise you. Picture this. You're trying to get from New York to Tokyo, but instead of flying around the curved surface of Earth, you could somehow tunnel straight through the planet's core. That's essentially what a wormhole represents for space travel, except instead of tunneling through rock, you're tunneling through the fabric of space-time itself. Back in 1935, Albert Einstein and his colleague Nathan Rosen discovered something extraordinary hidden in the mathematics of relativity. Their equations suggested that under extreme conditions, space and time could fold in on themselves, creating what we now call Einstein-Rosen bridges, or more popularly, wormholes. Think of space-time like a cosmic subway system. Normally, to travel between distant galaxies, you'd have to take the slow surface route, limited by the speed of light. But a wormhole would be like an express tunnel, connecting distant stations instantaneously. You could step into one end near Earth and emerge moments later in the Andromeda Galaxy, 2.5 million light-years away. But here's where reality gets complicated. These cosmic shortcuts come with a catch that sounds like something from a fantasy novel. To keep a wormhole open long enough for anything to pass through, you'd need something called exotic matter, material that literally weighs less than nothing. It's matter with negative energy density, and we've never found anything like it in nature. Even more mind-bending, most wormholes would collapse faster than light itself could travel through them. It's like trying to run through a tunnel that's caving in at the speed of light. The mathematics work perfectly, but the engineering challenges are, quite literally, otherworldly. What if instead of tunneling through space, we could surf it? In 1994, a Mexican physicist named Miguel Alcubierre was watching Star Trek when he had a revolutionary thought. What if warp drive wasn't just science fiction? What if you could actually make it work within the laws of physics? Alcubierre's genius was realizing that while nothing can travel faster than light through space, space itself has no speed limit. His drive works like a cosmic moving walkway. Imagine you're standing on one of those airport walkways, but instead of the walkway moving, the floor in front of you contracts, pulling you forward, while the floor behind you expands, pushing you along. The spacecraft never actually exceeds light speed locally. It sits comfortably in a bubble of normal, flat space-time, like a surfer in the calm center of a massive wave. But that bubble rides a wave of compressed and expanded space that can move faster than light itself. From the outside, you'd see the ship disappearing into the distance at incredible speeds. From inside, you'd feel nothing at all. The original calculations were staggering. Alcubierre's drive would require the energy equivalent of converting the entire mass of Jupiter into pure energy. But here's where the story gets interesting. Over the years, clever physicists have found ways to dramatically reduce these requirements. Chris Van den Broek figured out how to shrink the energy needs by orders of magnitude. Today, we're talking about energy requirements that, while still enormous, are at least theoretically achievable. NASA's EagleWorks laboratory has actually conducted experiments searching for warp signatures in the lab. They're not building warp drives yet, but they're taking the first tentative steps toward understanding how space-time might be manipulated. It's like the Wright brothers' first flight, except instead of conquering the sky, we're learning to bend the universe itself. But what if we don't need to break the laws of physics at all? What if the key to reaching the stars isn't about going faster, but about bringing everything we need with us? Enter the generation ship, humanity's most realistic path to the stars. Picture a city that decided to pick up and move to another continent. Except the journey takes 1,000 years, and the destination is another star system. These aren't just spacecraft, they're entire worlds, spinning slowly through the cosmic void, carrying tens of thousands of people who will live, love, work, and die during the centuries-long journey to a new home. The most famous design is the O'Neill cylinder, conceived by physicist Gerard O'Neill in the 1970s. The engineering is challenging but achievable with advanced versions of technology we already understand. Nuclear fusion drives could accelerate these massive ships to perhaps 10% of light speed. Closed-loop life support systems would recycle every molecule of air and water. Advanced manufacturing would allow the ship to repair and even expand itself during the journey. But the real challenges aren't technological, they're human. How do you maintain a stable society across dozens of generations? How do you preserve knowledge, culture, and purpose when the destination is so far in the future that it's beyond the imagination of those who begin the journey? These ships would need to be more than vehicles. They'd need to be entire civilizations, complete with governments, economies, and cultures designed to last for millennia. Some researchers are already working on these problems. Project Hyperion is studying the social and psychological challenges of multi-generational space travel. They're asking questions like, what happens if a generation decides they don't want to continue the journey? How do you prevent the ship's society from fragmenting or becoming authoritarian? These aren't just engineering problems. They're questions about the very nature of human civilization. While we're dreaming of wormholes and generation ships, one project is actually taking the first real steps toward interstellar travel right now. It's called Breakthrough Starshot, and it's so audacious it sounds like science fiction, yet so simple it might actually work. The idea is beautifully elegant. Instead of sending massive ships, send thousands of tiny probes, each no bigger than a postage stamp and weighing about as much as a paperclip. These starships would carry cameras, computers, and communication equipment, all miniaturized to an almost unimaginable degree. Attached to each would be a light sail 4 meters square, made of materials so thin they're almost like solid light. Here's where it gets incredible. A massive array of lasers on Earth's surface, covering an area of several square kilometers, would focus their combined power on these tiny sails. For about 10 minutes, these probes would experience acceleration forces of 10,000 times Earth's gravity, reaching 20% of the speed of light. At that speed, these starships would reach Proxima Centauri, our nearest stellar neighbor, in just 20 years. Compare that to the 40,000 years it would take our fastest current spacecraft. When they arrive, they'd have just minutes to photograph any planets they find before racing past at 60,000 kilometers per second. Then begins the 4-year journey for their signals to reach Earth. The project was announced in 2016 by tech billionaire Yuri Milner alongside Stephen Hawking and Mark Zuckerberg. They've already tested prototype sprites in space, proving that electronics can be miniaturized to this extreme degree. The engineering challenges are immense, but they're the kind of problems that can be solved with enough time, money, and brilliant minds. Think about what this means. Within the next few decades, we could have our first close-up photographs of planets orbiting another star. We might discover oceans, continents, maybe even signs of life on worlds that have been nothing but points of light in our telescopes. It would be humanity's first step into the cosmic ocean, our first real journey to another star. But Breakthrough Starshot is more than just a mission to Proxima Centauri. It's a proof of concept for an entirely new approach to space exploration. If we can send gram-scale probes to nearby stars, what about kilogram-scale probes? What about eventually sending larger payloads that could actually land and explore these distant worlds? The universe is vast beyond human comprehension. The nearest star is so far away that if Earth were a marble, Proxima Centauri would be another marble 4,000 miles away. Yet for the first time in human history, we're not just dreaming about crossing that gap, we're actively working on the technologies to do it. But perhaps the most important question isn't how we'll reach the stars, but why? What drives us to look up at the night sky and feel that irresistible pull toward the unknown? Is it curiosity, survival, or something deeper, something written into the very core of what makes us human? Throughout history, humans have been explorers. We've crossed oceans, climbed mountains, and ventured into the most hostile environments on Earth. Space is just the next frontier, the next impossible challenge that calls to something fundamental in our nature. But interstellar travel represents more than just exploration. It represents the ultimate insurance policy for our species. Earth won't be habitable forever. In about 1 billion years, our sun will grow hot enough to boil away our oceans. Long before that, we face more immediate threats: asteroid impacts, supervolcanic eruptions, climate change, or even threats we haven't imagined yet. Becoming an interstellar species isn't just about satisfying our curiosity. It's about ensuring that human consciousness, human creativity, and human love survive no matter what happens to our home world. But there's something even more profound at stake. Every approach to interstellar travel forces us to think about what it means to be human across vast scales of time and space. Generation ship passengers would need to maintain their humanity across centuries of isolation. Wormhole travelers might need to grapple with the philosophical implications of instantaneous travel across cosmic distances. Even breakthrough Starshot raises questions about how we'll maintain our connection to robotic ambassadors exploring distant worlds. These technologies aren't just about getting from here to there. They're about expanding the very definition of human experience. They're about ensuring that the music, art, literature, and love that make life meaningful can flourish not just on one small planet, but throughout the galaxy. So when might all this actually happen? The timeline varies dramatically depending on which path we take. Breakthrough Starshot could launch its first interstellar missions within the next 2 decades. We might have our first photographs from another star system by the 2040s or 2050s. Generation ships are a longer-term prospect. The engineering challenges are immense but not impossible. With sufficient international cooperation and funding, we might see the first generation ship launched by the end of this century. The passengers who board that ship would be betting their lives, and the lives of their descendants, on humanity's ability to build a sustainable civilization among the stars. Wormholes and warp drives remain the most speculative. They might be impossible, or they might be discovered tomorrow. That's the nature of breakthrough physics. It's unpredictable by definition. But even if they prove impossible, the research into exotic matter and space-time manipulation is advancing. Our understanding of the universe in ways that could lead to technologies we can't even imagine yet. What's certain is that the work is already underway. Right now, engineers are designing better light sails, physicists are searching for exotic matter, and social scientists are studying how human societies might function during multi-generational journeys. The future of interstellar travel isn't just being imagined, it's being built, one breakthrough at a time. And here's the most exciting part. You're living through the beginning of this story. Future historians might look back at this era as the moment when humanity first seriously began its journey to the stars. The children being born today might be the first generation to see images from another world, or even to board the first interstellar vessels. The universe is vast, ancient, and filled with wonders we can barely imagine. For billions of years, Earth has been an island of life in an ocean of space. But that's about to change. Whether through the exotic physics of wormholes and warp drives, the patient engineering of generation ships, or the elegant simplicity of light sails, humanity is preparing to take its next great leap. The stars that have inspired poets and dreamers for millennia are about to become destinations. The light that has traveled for years to reach our eyes will soon carry our own signals back into the cosmos. We stand on the threshold of becoming not just a planetary species, but a galactic one. The stars that have inspired poets and dreamers for millennia are about to become destinations. The light that has traveled for years to reach our eyes will soon carry our own signals back into the cosmos. We stand on the threshold of becoming not just a planetary species, but a galactic one. The stars are calling, and for the first time in human history, we're finally ready to answer.